Our next section in this unit is going to start looking at some angles. We're going to talk about two different ways to measure angles, degrees that you're very familiar with, as well as this other unit of measurement called radians that we'll get into. And we'll see how this relates to this thing called the unit circle. And then in the next section, our final section, we're going to look at, we will connect all these angles in section 10.2 with the trig stuff that we looked at in section 10.1. So we're on page 7 in the notes, and we first need to talk in standard position. And before we do that, I need to actually give you a definition of an angle. Our definition of an angle is an angle is formed by taking a ray and rotating that ray about the origin. So I've got a ray over here. I'm going to rotate that about the origin. Perhaps something like that. And the stuff inside there is my angle. And I'm usually going to label my angles using the Greek letter theta. That's my angle, angle theta. We say that an angle is in standard position if its vertex is at the origin and one ray is on the positive x-axis. So I have got my ray on the positive x-axis over here. The vertex is at the origin. This angle is in what I call standard position. As always, feel free to pause this video if the notes are going a little bit too fast for you. And by the way, all these bullet points should just be written on the top of page 7 in your notes. To label a couple things, that point in the middle is called our vertex. The ray that's on the x-axis we call the terminal side. This ray over here is the, sorry, not the terminal side, called the initial side of our angle, where our angle is starting, the initial side. I think I might have just inadvertently told you the other one. The ray after it's been rotated, where we end up, is called the terminal side of our angle. So I've got my vertex over here. I've got my initial side, the ray that's right on the x-axis, the positive x-axis. And the terminal side is that ray that started on the positive x-axis and has been rotated to end up over there. If our ray is rotated counterclockwise, we say that theta is a positive angle. So if I'm spinning in that direction, that theta that I just traced out is some sort of positive angle. We also have negative angles, which you might not have dealt with before. And we're just going to create a negative angle by rotating our ray clockwise. So over here, this angle that I just traced out, that angle theta, would have a negative measurement to it. A positive angle involves us rotating that ray counterclockwise, and a negative angle if we're rotating our ray clockwise. Again, please feel free to pause this video to get the stuff down in the notes. And again, this should also be in the top half of page 7, just some bullet points we're going to write in that space. So what we're going to try to do now is draw some rough sketches of a couple angles. By rough sketch, what I mean is I need to see the initial side of the angle. Those are already drawn in on those 4 little things of axes. And I need to see the terminal side of the angle, and then I just need to see how we were spinning our initial side to get to our terminal side. So here's what I mean by this. 36 degrees. First of all, this is a positive measurement of an angle, which means I'm going to spin my initial ray in the counterclockwise direction. Now, I know that if I spin it 90 degrees, it will be sticking straight up. That's too much. I don't want to spin that much. So I'm just going to spin a little bit. If I spin like this much, that's about 36 degrees. That works. When you draw these things, you need to show me the initial side, the terminal side, and that little symbol inside showing you what direction I was spinning to get to my 36 degrees. That little curved arrow with the arrowhead at the end. That's 36 degrees over there. No, I'm not going to be able to tell the difference between 36 degrees and 35 and 34. I don't care about you being super precise and using a protractor and any of that stuff, but I do need your angle to end up in the correct quadrant. Next, 315 degrees. Well, this one's another positive angle, which means I'm going to spin counterclockwise. I know if it was pointing straight up, that would be 90 degrees. I know if I continued to pointing directly to the left, that would be 180 degrees, so I need to keep going. I know if I was pointing straight down, that would be 270 degrees, still not enough. I know if I went all the way around, it would be 360, so I need to be between 270 degrees and 360 degrees. My angle is going to look like this. And when you fill in your marking, it needs to go kind of on the outside part of the thing. If you put the little marking inside the acute angle over there, that would actually represent something different. 315 is this angle over here. The angle is not just the initial ray and the terminal ray, it's also the rotation we were using. And in this case, it was this rotation counterclockwise that started in quadrant 1, went to 2, 3, and ended in 4. Negative 150 degrees. Well, we have a negative angle over here, which means I'm going to spin that initial ray in the clockwise direction. I know that if I spun negative 90 degrees, it would put me pointing straight down. And I know if I spun negative 180 degrees, it would put that angle pointing directly to the left. So I need between straight down and directly left. Negative 150 will look like this. And again, make sure you're putting that little arc marking with the arrow at the end to show how you were spinning to get that angle. You take a moment and see if you can try negative 225 degrees. See what you can do. So we're spinning clockwise this time because it was a negative angle. Negative 90 would put me here. I need to go more. Negative 180 would be there. More. This is negative 270. No, that's too much. It's got to be between negative 180 and negative 270. And it should look like that. And I've got my angle of negative 225 degrees. Now, again, that arc marking with the arrowhead at the end is very important. If you just showed the initial ray and the terminal ray, I wouldn't know. Did you go negative 225 degrees? Did you go some positive angle, maybe positive 135 degrees? We have a bunch of angles that will end in the same place, but you get there in a different way. And these angles are called coterminal angles. Next thing we're going to define. Coterminal angles are angles in standard position that have the same terminal side. Coterminal angles are angles in standard position that have the same terminal side. We're going to get that in the notes on the bottom of page 7. Let me show you what I mean by this. You do not need to copy down these 4 drawings. Just watch. These 4 angles are going to be coterminal. Again, don't copy, just watch. 100 degrees, well, 100 degrees looks like this, spinning counterclockwise, that much. Negative 260 degrees, I'm going to spin clockwise, and I'm going to spin 260. Those are different angles, but the initial ray and the terminal ray are in the same position. They're different, though, because you got there in a different way. Just like 460 degrees. Well, I know 360 degrees would be a complete rotation, so I'm going to go a little bit more than a complete rotation. Take a look at 460 degrees. Another coterminal angle ends in the same place, but you got there in a different way. Negative 620 is another coterminal angle, looking something like that. These are all coterminal. They end in the same position, but you get there by spinning in a different way. Well, to find coterminals, coterminal angles, all we need to do is take the angle that was given and add or subtract multiples of 360 degrees, which basically means we're going to take our angle and we're going to add another spin around in some direction, either in the positive direction, which would be adding 360, or in the negative direction, which would involve subtracting 360. And we can do this as many times as we want. That's why I'm saying multiples of 360 degrees. So let's on the top of page 8, I want to find a positive angle and a negative angle coterminal with those two things. Well, in letter A, I'm going to take negative 45 degrees. I'm going to add 360 degrees to it. And when I do that, I'm going to get 315 degrees. If you drew out negative 45 degrees and 315 degrees, again, you would get there in a different way, but they would both have the same terminal side. Another angle that would be coterminal with negative 45 degrees would involve me taking negative 45 degrees and subtracting 360 degrees from that. Well, if you do negative 45 degrees minus 360, you'll get negative 405 degrees. When you're finding coterminal angles, I do need to see the work. It's not a lot of work, but I need to see that you're adding 360 or that you're subtracting 360. Actually, in this case, I did one of each. I added 360 and I subtracted 360. In letter B, we could certainly take 395 degrees and add 360 degrees to that. We would get a positive coterminal angle. However, if I subtract 360 degrees from this, actually, no, let me start with that again. 395 degrees, add 360 degrees, we get 755 degrees, a positive coterminal angle. If I then go back to 395 and subtract 360, I get 35 degrees, another coterminal angle, but that's also a positive angle. Either of those would count as the positive angle coterminal with 395. But I also said in the directions I want a negative angle coterminal with 395. Well, remember that our directions was to add or subtract multiples of 360. I added 360 once, subtracted 360 once. I could subtract 360 again from this thing. I could do 395 minus 360 minus another 360 minus 2 of those 360s. I think the easier way to do that, though, is to take the answer that I got after subtracting 360 once, that 35 degrees, and just subtract another 360 from that. I'm going to do 35 degrees minus 360 degrees, and that's going to give me negative 325 degrees. Once you have a coterminal angle, you can subtract another 360 to get another one, which is how I took my 35 degrees and got negative 325 degrees from that. By the way, when you're writing answers, make sure you're putting that little degree sign in there, because we're going to see the next day that without that little degree sign, we're actually talking about angles in terms of radians, another way to measure these things. We'll deal with that next time. Last thing we're going to look at, put some ideas together. And I would like you to take a few moments, pause the video, and try to do those examples in the bottom of page 8. I want you to draw the initial angle, 65 degrees, 230 degrees, negative 300 degrees, and 740 degrees. And then when you're done, I want you to find two coterminal angles with both of these. So basically, we're just putting everything we've done today together in 4 examples. Draw the initial angle, and then use your calculations of adding 360 or subtracting 360, possibly more than once, to get your positive coterminal and negative coterminal angles. Pause the video and see what you can do. Hopefully by now you've tried those 4 examples. Letter A, 65 degrees, is going to look like this. And to get my 2 coterminal angles, I'm going to do 65 degrees plus 360. That's 425 degrees. Then a negative coterminal angle, 65 degrees minus 360 degrees, that gives me negative 295 degrees. Letter B, 230 degrees will look like that. Add 360 to it and subtract 360. Make sure you're showing the work to get two coterminal angles of 590 degrees and negative 130 degrees. In letter C, negative 300 degrees will look like that. Take negative 300, add 360, and subtract 360 to get your two coterminal angles of 60 degrees and negative 660 degrees. Finally, in letter D, 740 degrees. Well, I know that one time around is 360, two times around is 720, so 740 is a little bit more than two whole times around the unit circle. I could go and I could add 360, but rather than doing that, I'm just going to subtract. Subtract 360 once you get 380 degrees, which is the equivalent of going one whole time around with a rotation, then a little bit more. You can take that answer and subtract 360 from that to get 20 degrees, another positive coterminal angle. And then you can take that answer and subtract 360 degrees from that to get negative 340 degrees, our final negative coterminal angle. And really, you could keep doing this as many times as you want. There are infinitely many angles that will be coterminal with any given angle. You can just keep adding 360 as many times as you want and subtracting 360 as many times as you want.